Hey everyone, so we're going to go ahead and get started here on our Pygame game here. This video I'm probably going to just be working on, you'll see me bounce around a lot of files. I'm not just going to like say, all right, now we're going to make the entity state file and just stay in it and fully complete it. I'm going to bounce around real fast in a bunch of different files. And as this series goes along, I might go back into files and change things, and you'll see. But right now, I'm going to kind of get our project structure set up. So in our root directory here, I just have it called Advanced Pygame Tutorial. Let's make a new directory called src for source, and that's kind of where I throw all my source files. If you're using PyCharm, make sure you right-click this file and go to Mark Directory as Sources Root. That way all your imports work properly. If you don't do that, you'll have issues where it says it can't find certain files. Inside our sources root, we're going to make a few more directories. I'm going to have one called fonts. That's where we can store fonts. I'm going to make another one called images. That's where we can put all of our images. Another one called music. Another one called sounds. Let's see what else we need. Fonts, that should be all for right now. Now let's make, I'm actually going to make our main file. Go ahead and get it started. So we're going to make a main function, and I'm going to pass right now. You'll see me do this a lot. I'll make a function just as a placeholder and put pass, and then later on we'll come back in here and write code in it. But this is just kind of the standard way to get your main file set up. So we'll do the if name equals main. Then run our main function. Okay, so that's kind of that file for right now. Let's go ahead and work on we'll make a Python file called constants, and we're gonna add a lot of stuff in here. So I'm gonna make, let's do some display information and I don't know, scaling and FPS. So for our scaling and FPS, I'm gonna put a couple things in here. Full screen equals 0. So this is kind of just a flag. It says if the game is if it's in full screen or not. By default, we're gonna have it turned off for right now. Scale is gonna equal 1. What this is gonna check for is the scale. So our resolution for the game was 480 by 270. So at a scale of 1, the display, not the native resolution will always be 480 by 270. That is like the resolution of this 16-bit game we're making. But the scale value right here is for our actual window. So if it's at a scale of 1, then the display also equals the resolution of our game, 480 by 270. But if it's at a scale of 2, it'll be double this. If we do a scale of 4, the display, the window, will be 1920 by 1080, but our game's internal resolution will still always be 480 by 270. So that's what scale's for. Then FPS, our game's going to be 60 FPS. All right, so display information. This is going to have a bunch of variables, and I'll explain why it has a lot of these in a second. But we're going to make a bunch of variables for our native resolution. So I'm gonna do native width equals, what was it? All right, 480, and native height equals 270. And then I make another one called native size, which is just a tuple that contains the width and the height. Because a lot of things in Pygame and a lot of things we're gonna create will want both of these values in a tuple form. So we'll just make that variable right there. Now what I also wanna do is I wanna make a bunch of variables that have different coordinates for the screen. So like top left, the top right, going clockwise. So we have top left, top right, right center, bottom right, bottom center, bottom left, and then left center. That way if we ever have any functions where we want to position things easily on the screen, we don't have to supply a ton of coordinate information. We can just reference all these coordinates we have in our constants file. So we'll do native native top will just be 0 because the top of the screen on the y-axis is 0. Native right equals the far right side of the screen is going to be the same as the width of the screen. Native bottom is the same as the height, so that will just be height. Native left is also equal to 0 because 0 on the x-axis is left. So now let's do the actual coordinates for like top left and all that stuff. So native top left is going to equal the XY coordinate for the top left of the screen, which is just 0, 0, but we can do, yeah, we can just put 0, 0 for that. So 0, 0. Native top center, and that's going to be, oh, actually we need to do something because I like to keep this organized. So we have native width, height, size, top right, bottom left. I also like to do, put it right here, native width center, which is just going to be native width divided by 2, and native width, or sorry, native height center is native height divided by 2 because we'll be using these down here. So native top center on the x-axis will be the same as the native width center, and it will be native top. And I don't like putting these 0, 0 here. I'm actually going to do native left and native top. That's the same thing as 0, 0. It's just we have these variables already, so we should just go ahead and use them. Make sure native left, yeah, left and native top. So we got the top center. Now let's do native top right. So the top right on the x-axis is the same as native width, or the top right. So on the x-axis it would be, the native width would be all the way on the right, so it's the same as the width. And then it's just the native top on the y-axis, which is 0, if that makes sense. So now let's do native right center, which is going to be a tuple of on the x-axis. Sorry, I gotta think about this. On the x-axis, it's also native width because it's all the way on the right, and then it's actually native height center on the y. You can kind of, I don't have to keep talking about all this, but you can kind of figure it out and just read it as I'm typing. So let's do native bottom right, which is actually the same as the display size. So you can actually just do native size on that. Native bottom center equals the x, that's going to be native width center and native height. And native bottom left is going to be native left and native height. Native left center equals native left and native height center. So hopefully all that makes sense. I know this looks like a lot, but I like to do this because later on we're going to implement a bunch of functions that actually reference all these coordinates, and it's very easy just to have them already made to where we don't have to keep entering all this coordinate information and stuff like that. And I also want to make one more. I want native, just native centers, which means the center of the screen, which is just going to be native width center and native height center. Now what we need to do is the exact same thing, but we need to do it for, this is all the native resolution coordinates. Now we need to do the display, like, because the coordinates will kind of be different when the display actually scales up. So let's do display width, which is going to be our native width multiplied by whatever our scale value is. And the same with the height. And display, so, and we're pretty much repeating all this stuff, but just using the word display. I'll show you a really kind of easy way you can do this in a second. So all this stuff we can actually just copy right here, paste it, but wherever it says native, you can highlight one of them and hold down the Alt key and just highlight everywhere it says native. And sorry, this is kind of tedious, but let's just do those. Display, you just change it to the word display. We'll go back and grab the rest of them. And there's probably a faster way to do this, like some find and, I know there's like a find and replace method, but this is just how I do it. Display. Gotta clear that. All right. So that's all of our display information. I also want a section for directory information. So this is just like file paths to our directories that we might need to access. So we don't have to type the file path to the directories all the time. I'm probably going to end up changing this later on using the OS module just to find the file paths. But for right now, this is how I'm going to do this. So I'm going to make a constant called dir for directory, and we'll just name it like fonts. And that's going to, you can do a lowercase r here so you don't have to type the multiple slashes. So we'll do what I make. So yeah, r fonts, and we have images equals r slash images. Why does it not like this? Missing closing quotes. Oh, I think you might have to. What am I not seeing here? I'm pretty sure, I haven't used this in a while, but I'm pretty sure you can do R and it allows you to just, well, we won't do that. I don't know why it's complaining about the double quotes. I'll look at that later. We can just do, we'll put the double slashes for right now. That still works. Whoops. All right. Another reason you don't want to use, you don't want to do it like this, and we'll probably change it later. Say someone runs this on Linux or Mac, the slashes are actually facing the opposite direction. So if they run this, it's going to give them an error message saying it can't find that file path. Well, let me check something here. All right. Yeah, so which is why we're going to change this later on. But for right now, this will work just fine. What else we need in here? We're eventually going to have a bunch of stuff that has to do with controller data, like the PlayStation and Xbox controllers, but I'll leave that out for right now. So, okay. Now what I want to do, let's go into our source directory. I'm going to go ahead and start making a bunch of files. It's just things I know we're going to start working on kind of all at the same time. Right now, all we have is our main main function. And actually, before I make the files, I'm going to go ahead and just write our main function because it'll be really short. So the first one we need, I'm going to make a file called init, and it's just going to contain a bunch of functions that kind of initialize our program for us. So when let me actually go up here. let me go ahead and just do import init, because I am going to make a file that has that. And init's going to contain a bunch of functions that just set up everything for our game. So we're going to do, we're going to need a display. And init will have a function called getDisplay. We need a clock. Init will have a function called getClock. We need game states, all the states of our game. And init will have a function called getGameStates. And then we need a controller object, and init will have a function called getController. We don't need to type the word object, but yeah, there you go. And then this is all the setup we need. We're going to be tweaking something in here in a second, but once we have our controller, which is, remember, that's like the brain of our whole program. Once we have this controller and it's set up from all this stuff above it, the controller can have a method called run game, and this is, as soon as it hits this is the loop where the game plays and you start playing it. But at first we need to set up all this stuff right here. So a controller, in order to make a controller object, it's going to need the display that we got up here. It's also going to need that clock. It's also going to need the game states, and it also needs to know oh, that's one other thing we got to add. It also needs to know what, out of all the game states we just provided it, what state should it start on. So what I'm going to do is I'm going to type this, and I'll explain in a second. I'm going to import our constants file into here. And let's go back to our constants file real quick. Oh, look, I accidentally put our constants file outside of the source directory, so let's move that into there. Yeah, that's another thing we need. So right here, we're going to put game state information. This is just going to have some, all of our game states that we can have in the game. It's just going to have constants, and they pretty much just equal a string of what the game state's called. You can do this a million different ways, but it just allows us to use, instead of, when I show you how game states know how to flip to different states when we actually make the controller and game state objects, it uses it, the way it knows how to change to the appropriate state is you pass in a string of the name of the state. But I don't want to pass in a hard-coded name. Instead, I would like to make a variable called splash screen, for instance, and it just equals the string splash screen. That way, every time the state object needs to change, it can just reference this variable here. We don't have to hard code the string splash screen, even though you could. This is just how I like to do it and have it organized. And again, when we get to actually making the game states, this will make more sense. But I'm going to start putting some states in here that I think our game might have. But your game, you can have whatever. So we'll have a splash screen, a main menu. I have an idea in my head for how I want, the ending game to be. I'm going to have a character select screen, because I think that'll have a bunch of cool stuff we can show off. If we make the game to where you can have multiple characters, there's a lot of cool stuff I can show you. We'll have our level state, and that's probably all we need for right now. But then what I want to do is I want to make a list called game states, and it's just a list of all those states that we just made. And then I want a variable called starting state, and that's just going to equal whatever the first thing is in that list. Again, there's a million different ways you can do this. This is how I just like to organize it. So we made all of our game states right here. They're just strings that say the name of the state. We threw all those into a list called game states, and it's just saying our starting state is the first thing in this list, so it'll be the splash screen. So let's go to main. Now that we've made that, the controller object's not complaining that we don't have a starting state now. So we clearly don't have this init file that we need to make. So let's make that. Let's make a Python file, init.py. we're going to need to import Pygame and import constants as C. And I have not installed Pygame yet, so let's do that. If you don't know how to install Pygame, it's you just go to your scripts folder. Actually, did I go to the wrong folder? I think I did. But I guess it works anyway. I usually go to the scripts folder and run this, but I guess you can do it. Yeah, it looks like it works. Yeah, so you can just go to your virtual environment folder and do pip install Pygame, and it should work. All right, so we're in our init, and remember we had a function called get display, and let's do this. So we're going to make a display object, which equals pygame.display.setMode. This is all basic Pygame stuff right here. Now the display, we don't want to pass in native resolution. We want to pass in the actual size of the window, so it'll be display size. This get display, we're also later on in the future going to be tweaking a lot of stuff in this function, but for right now it's just going to get a display like a basic Pygame game would. Return display, so that's all that one does. We need a clock, so we'll do clock equals pygame.time.clock, return the clock. What was the other? We need get game states. Game states. All right, our game states, the way they're going to be stored in a dictionary. And the key is the name of those, the constant variables we just made. These right here, these will be the keys to accessing the actual game state objects. We haven't made the game state objects yet, but the key to accessing them is just the string of the name of the game state. So let's go to init. And we don't have it yet, but it's going to be called splash screen. One thing you might do, this is going to be an actual class, and one thing you might be tempted to do when you do this is say we have a bunch of them in here, or I'll just do 2 for right now. Say we have 2 of them in there. You might be tempted to put the parentheses right there, like we're creating an object. You don't want to do that though. You just want to kind of like load this is probably just loading like the memory location of that class, and we're not actually creating an object of the splash screen yet. We're just kind of preloading everything, and then our controller will actually create an object of these. But don't put the parentheses there. I remember when I was first doing that, I did that, and you'll run into some issues if you do it that way. So for right now, I'm only going to put 1 state in here, but after this is done, all of our game states will be in here. And then we'll just return the game states dictionary. And then what we need to do is get controller. And remember, the controller requires a display, a clock, game states, and starting state. And what that's going to do is it's going to equal a controller object that we'll make in a second. And we'll pass the display, clock, game states into that, and starting state. And we'll return the controller. So a couple things. Because we haven't made the splash screen object yet and this thing's complaining at me, I'm going to go ahead and type, we're going to make an actual file called splash_screen, and that's going to contain the splash screen object. It doesn't exist yet, but I'm just typing it up here so this thing stops complaining at me. And the same with the controller. So we're going to do from controller, import controller. And that's the next thing we're gonna make. But I see this video is already 25 minutes long. In the next video, I'm gonna go ahead and work on the controller object and probably the base game state class. I don't know. Like I said, I probably won't just sit here and focus in one file because that's not really how it works. You kind of have to bounce around a bunch of them and do little things in each one at a time to get it to work. But yeah, I'll see you guys in the next one. The next one we'll mainly focus on that controller object. So you guys have a good one.